Greetings, everyone. Welcome to our exclusive Global Leading Voices webinar campaign. We are delighted to have you join us here today. Please be informed that if you have any questions during the presentation, you may type them into the question box in your control panel. The presenter will answer your questions at the end of the presentation accordingly. Now, without further ado, we will turn the time over to our presenter, who will begin shortly.
Welcome everybody. Good morning, good afternoon, good evening, depending on which part of the world you're in. Today I'm going to talk about security modeling, modeling security concerns in IT systems. Now I'm aware that modeling in most engineering disciplines is nothing new. But to set a context for this talk, I'd just like you to imagine for a moment that you were working in aircraft design, not in IT systems, but you were designing airliners, and you had a beautiful state-of-the-art computer-assisted, design and modeling framework where you could model the aircraft's, the electronics, the hydraulics, the avionics, the fuel systems. But when it came to safety, there was no safety modeling built into the CAD system. What you had to do was engage sort of like a high-powered consultant, pay them a handsome fee. They would review a few documents, write a few reports, and sort of like declare it more or less okay as far as they could see. You wouldn't quite have the same sort of confidence in the safety of that aircraft as if it had been designed with the same automated tooling that the rest of the mechanics had been. And yet, from what I observe as to the way we design our IT systems today, some of the most complex systems, that mankind has ever built, we're using a certain amount of tooling in the software development life cycle, in the business process modeling, maybe in the way the networks are managed. But when it comes to security, it's very often a case of calling in the witch doctor. We don't have that same set of engineering rigor that most other engineering practices have. So in this presentation, I'd like to look at some ideas about how we might do this better and why we need to do something better. So with that, we'll start the first slide. I'm going to start right from the very basics. I'm going to look at what do we mean by a model and what are the benefits of modeling. And then look in particular what kind of things we want to achieve through our security models. What are we trying to accomplish by doing this modeling? And once we've established what we're trying to do, I'm going to look at the capability of using ArchiMate as our security modeling notation. So see what it's capable of, where its limitations are, and where we might hit limitations not through the language itself, but in what you're available to do through the tool support that's available for it. And then once we've looked at the capabilities of ArchiMate doing in ArchiMate, we're going to look at some examples of just modeling in practice, some sort of practical steps and examples of what you can do in ArchiMate with regards to security, and then some ideas about future directions where this might go in the next coming years. So straight into that, then what do we mean by a model, and what are the benefits of modeling? Well, models don't need to be as complicated as computer-aided design and modeling systems. We don't have to design aircrafts on day one. Even something as simple as an old-fashioned map is a kind of model. It's something where if you can identify your surroundings and place them on the map, what you're presented with is a simplified representation of a real-world system. And if you can pick out the features of where you are and where you want to get to, the map just basically gives you, a route sets you off in the right direction. But even a map can be better than this. Just as a simple for modeling, it's not just something you can use for reference. A model is something you can use for solving problems. So even with this simple example of a map, we can look back to sort of the classic 7 Bridges of Königsberg problem, from the 18th century. And for those that are not familiar with it, this was a situation where the Emperor of Prussia, to celebrate some anniversary, wanted to do a parade around the city of Königsberg in Prussia, and he wanted to visit every part of the city but cross each bridge exactly once. right? And he gave this problem to his courtiers to plan the ceremony, and they couldn't figure out a route. So what they did after they'd given up, they called in the most eminent mathematician of the day, a man called Leonhard Euler, and he took the problem, and even with the map like this, he reduced it even further into a simple topographical map where he identified the land masses as nodes and the bridges as links, and he just created the simplest representation possible. 4 nodes, a number of bridges as links, and he theorized that in order to solve the problem, to parade through the city, visiting every part but crossing the bridges exactly once, that this map had to have a particular property. And that property was that with the exception of the node where you start and where you finish, every other node has to have an even number if you count the number of links associated with each island. So once he'd done that, he could see that this problem actually was intractable. It didn't have a solution, because for it to work, you say, apart from the start and end node, every node had to have a bridge to enter and a bridge to leave, an even number. And all the nodes had even number of bridges. Odd number of bridges. And further than that, he could solve the problem by specifying where the extra bridge had to be built. So this is an example of even a simple map being used, not just for documentation, but for analysis and for problem solving. And the branch of mathematics that this launched is graph theory. This is the branch of mathematics that actually is supporting the modern world. It's graph theory that tells, like Google, where the hubs and the reference nodes are on the internet. It tells Facebook, who are the people that are just beyond your immediate network. It allows Amazon to recommend something that you might like to buy given your past purchases. It's this theory of nodes and links. So I just put that in as an aside of how something simple can be very powerful. So what are the benefits of modeling? Why would we want to do this? Well, basically, if we can use our models, it's often earlier, cheaper, faster, safer, and more agile than interacting with a real-world system. So if you can present somebody with a model of the system that you're building for them and allow them to sort of play and explore it and analyze its behavior, you'll get better feedback earlier. And that produces better architecture. And it means that you commit yourself to the solution building blocks much later in the process, because your requirements are more complete, more clearly stated. And for instance, in software in the automobile industry, there have been studies that say, basically the more you can do your engineering modeling, the more time and money you'll save. So in the case of automotive software, if you can do model-based engineering, you can reduce costs by 27% and the lead time by 30%. And if your models can include the testing aspects of software, it's even greater, 40% savings, 50% savings. Now, given the pressure on IT to deliver faster in terms of like agile mindsets and the cost of security budgets, I think if modeling could even save us a fraction of that amount of saving, then we'd be onto a winner. So it's something that's well worth pursuing here. So what do we currently use as security models? Well, we see a number of things. We see attack trees, ways in which a vulnerability can be exploited or an asset can be exposed. We see threat modeling diagrams, looking at where the assets are, where they're placed, what the attack vectors are between those and potential attackers. We can look at privacy flow diagrams, looking at where sensitive data comes into our organization, who's using it, where it gets stored, where it gets handled, where it flows to as a sink. Or we can have something like this. When I started doing security, maybe about 10 years ago, this was the sort of recommended way by the sort of like the digital architectural risk analysis approach, where you basically draw a schematic where you create symbols to represent your servers and your data assets and your controls, and you mark it with the little red devils for where your attackers might be placed, and the gold is where the assets are that you want to protect, and the green is the controls that you try and place along the path between the attackers and the assets. And this gave, you know, a good visual representation of the system that you were trying to analyze, much better and easier to work with than a, you know, a 40-50 page description of the document. And you could say, like, sit down with your client and you know, do some basically check you had your understanding right, you had a complete system. You could do some rudimentary threat modeling with this, with a risk diagram. Okay, those are the little symbols on there. So in terms of what do we want our security model to do? Well, thinking about this, there's a framework called SABSA, the Sherwood Applied Business Security Architecture. And as far as I know, that's the most sort of complete and comprehensive and rigorous grid, if you like, of all the possible security activities that you might need to perform as a security analyst. It looks like a similar framework to the Zachman reference architecture, in that you have a number of layers that represent different stakeholders' view of the system, looking from the sort of like the business view at the top to the component architecture and the operational and management layers at the bottom. And you basically ask yourself the 6 questions that keep the system honest. It's like, you know, the what, why, how, where, when, and who. What are your concerns in each of that? And by analyzing security in terms of this grid, basically the SABSA framework says basically any activity you do has got a home in one of these cells. It's done at the right level by the right person, produces some kind of artifact that describes their particular view or concern about the security of the system. The problem is it's quite a heavyweight system. It's popular with, you know, defense contracts and critical infrastructure. And the reason it's kind of heavyweight is because each one of these cells produces at least one working artifact that has to be reviewed and approved, and has dependencies with the layer above, its peers on the same layer, and the documents that are derived from it in the layer below. So for instance, if you find that one of your artifacts in one of the cells undergoes a review cycle and changes need to be made, they could very well impact related documents on the same layer, which then will need to go into a review cycle. Or it could change something about the way you want to you do a risk treatment, decide you're going to avoid that activity or do it a different way. The business layer has to change, or some of the implementation that follows from that document has to change. So very quickly, if you're doing, you know, SABSA to its full force and effect, you end up with quite a complicated document management lifecycle. So not only are we looking out for our model to actually support all these different types of artifacts that the SABSA grid tells us that we might need to do, we actually want to make sure that we don't kill ourselves with document management overhead in the process. Okay, so we're looking for more than documentation. We're looking for an interactive model. So going back to sort of the best of breed of what we had for like 10 years ago, the digital risk analysis diagram, it's good. It's kind of got a notation. It's easy. The tools are simply any drawing package like a Visio, but it's got a number of drawbacks. It's got a very limited scope, basically on the technical layers. You don't model, you know, the business processes that this is supporting or how critical they are. It's mainly got a technical focus, and even within that, it's mixing network components and data and applications, a mixture of technological and logical layers. It's an informal notation. It's just colored lines and boxes. No particular semantics attached to it. It's possibly there. It implies a constructive ambiguity where different stakeholders can kind of see what they want to see or expect to see in it. It doesn't necessarily throw up contradictions. Basically, it's just an annotated diagram, not meant to be machine readable, and yet good for creating a common understanding between the security analyst and the other stakeholders. It provides a focus for discussion, and let's face it, any documentation is better than nothing. It gives you at least something that you can say, this is what we reviewed, this was the scope at the time, this is what we took into account when we did our risk analysis. Okay, but not quite what we're looking for a model. So this is where we turn to ArchiMate. Could ArchiMate be the kind of solution we're looking for? It certainly fixes a lot of the deficiencies that we've had with the notations till now, in that it's a concise but expressive, kind of like semi-formal notation. There are several ways of expressing what you want, but as you draw it, it means something. It's got a fairly precise meaning. It's layered. It's capable of expressing motivation and strategy. Why you're doing things this way. It's a standard supported by the open group, so perfectly compatible with the TOGAF framework, which is the main system that architects are using. And because of that, there's an extensive choice of tool support, from very good free tools to enterprise level team sharing repositories that will support ArchiMate. It's been going around 10 years. Version 3 came out last year. 3.1 is due in November, so it's mature. And best of all, it's machine readable. It's underlying. These are not just diagrams. This is a model. This has got a semantic model underneath it that you can express in XML, and therefore you can interrogate it. You can machine process it. It's not just about the visuals, useful as the visuals are for expressing and conveying that understanding with your stakeholders. One more compelling thing about this ArchiMate, virtually every other type of enterprise architect that we encounter is using it. So if you think about it purely on economics, if the enterprise architects are using an ArchiMate tool, and the solution architects, and maybe the data architects, and the business architects, security architects are not going to get another tool. They're not going to get another parallel system that they have to maintain in sync with the main architecture model. There's only one real-world architecture. There should be one tool to represent it, one model to represent it. So in the end, I think as much as the strengths of ArchiMate make it feasible, the reality is security architects are going to need to have to use the same tools as other architects eventually anyway. Okay, so it's worth pursuing for both those sets of reasons. Now, the current state of SABSA, ArchiMate, and TOGAF, it looks a bit like this 4-quadrant grid here. We've got the kind of like the TOGAF representation in the top right corner. That's the theory of how we can do enterprise architecture, how we can align our IT systems with business needs. And for a while, 2011, 12, there was a position paper that aligned the SABSA security overlay in theory with TOGAF, and that's been reinforced in the latest TOGAF 9.2. That's not just like a position paper now; it's one of the guides in the library, the formal mapping between SABSA as a security overlay for TOGAF. So that kind of work has been done. We know in theory how to apply a SABSA approach to a TOGAF 9 or 9.1, 9.2 enterprise architecture development method. And of course, given that ArchiMate and TOGAF come from the open group, the alignment between the two of those things is natural. They're developed to stay in sync. So the question for us as security architects is how do we fill in that fourth quadrant? How do we do enterprise architecture in practice? How do we realize that theory, given we've got a tool, ArchiMate, that in theory represents TOGAF but hasn't absorbed the SABSA framework? Well, in practice, we do it like this. We do it the old way. We generate lots of artifacts, be they documents, matrices, drawings, presentations. We're falling into that trap of the documentation nightmare, where we're trying to create multiple models consistent with each other and up to date over time. So what we're trying to look for in this project in sort of ArchiMate is to try and overcome that, and that the major problem we've got basically is summed up by this slide here, that we have SABSA with its 5 structural layers and an operational layer, where the second from the top is the conceptual security architecture, the security analyst view of the system. And we've got ArchiMate 3 and 3.1, where that layer just simply doesn't exist. That's the obvious deficiency in the current state of ArchiMate. If we want to represent things like, you know, accounts and principals and credentials and trust domains, things that we would naturally describe in the artifacts from the conceptual layer, we don't have the notation to do it. There's another more subtle problem in there that's not quite so obvious, and that is that when we're doing security, it's not just a layer, it's a transversal view on all layers. So even when we're looking at something like the contextual layer, the business view of the system, where there is a piece of business information, the security architect will want to know what's the classification of that piece of business information, what's its confidentiality rating, what's its integrity rating, what's its retention period, does it contain personal information, right? So none of that is present in the current set of properties that attach to elements in the current ArchiMate model. So we've basically got two bits of work to do. We've basically got to identify what security properties we're interested in existing elements, and work out what we're going to do about that gap for the security view of the system. Okay. So what have we got to work with in ArchiMate? Well, there are mainly four ways of extending ArchiMate to make it suit a particular application. The first one is by stereotyping elements, basically saying that I'm going to create an element that is a type of, you know, a derivation of one of the existing notations. We can extend the notation, say, by stereotyping existing elements. That's one thing that is perfectly legal and encouraged to do. You can also add user-defined properties. Actually, ArchiMate native defines very, very few standard properties. So it's an area where, if we can define or agree on a security vocabulary, it's a great place to start annotating security information into existing models. We can also overload relationships. ArchiMate does this all the time. I'll go through the next set of slides, gives examples of what I mean, but this mean of all these things. But overloading relationships is basically saying that in two similar contexts, the relationship notation can be reused because the concept is similar, even though it's actually doing slightly different things in the two different contexts. It's a way of keeping the vocabulary small, but still making it intuitive. But if we can overload relationships within the normal model, we can overload them again for security reasons. And the fact that in the last year's version of ArchiMate 3, there were fewer constraints and restrictions on relationships in kind of like the order and the way that they were connected between layers, which for our purposes, where we're trying to insert a layer and rejoin everything up, makes it possible to do some things a little bit more elegantly than was the case in ArchiMate 2.0. Again, the obstacles we have to come up with are basically the core language specification. When we're trying to document our security concepts in ArchiMate, we make it a commitment that we're not going to actually break the specification, we're going to work within it. And then once you've got the notations sorted out, you have to make sure you can live within features that are provided by tools to make it easy to work with and not you know, adding extra workload. But the good news that for the majority of cases, it does look possible. And this is the subject of a paper that I'm working with the SABSA Institute, you know, the people that look after the SABSA security framework. And this is a paper that we're going to be launching at the COSAC conference in October this year. So there's a lot of detail in this paper about how you model different elements and what properties they need. Not the greatest format to present that detail in a presentation, but I'll pick out a few examples from here to give you a flavor of how this is being approached in this paper. Okay, so one of the things we have to do in security is basically, first and foremost, it's about the protection of assets. And ArchiMate in its notation actually doesn't have a native element for an asset. So one of the first things we have to do is work out how we're going to represent, assets and value streams, the things we want to protect using the ArchiMate notation. Now, although ArchiMate doesn't have an element asset, I mean, it would be quite an abstract element, what we do have is the value, the sort of oval that I've put at the top right of the screen there. And an asset or a value is something that you can attach to any element. So given that we may have existing ArchiMate models that have been drawn up by other architects, when we're looking to analyze them from a security point of view, we can provide asset value tags or elements to any part of that model to highlight the bits that we're interested in protecting, the things that we really care about. And it can be as simple as, say, as like having the value element associated with the element that you associate the value with. We can take that a little bit further. We can add some properties that say, well, is that value financial, or is it to do with reputation? Is it a legal or compliance thing? We can give them a kind of a notation of low, medium, high that allows us not just to note that there is value there, but actually to give it some quantifiable properties. We can also say to whom that value is important by inserting it in line between the stakeholder that values that asset and the asset which is the thing that we need to protect. Now, what I've shown there is kind of like the intuitive way of doing it, asserting the asset value in line. But with a bit of experience, in sort of medium and large scale models, you very often come under situations where multiple stakeholders see the same value in one asset, or they see the same value in multiple assets, and that even though your diagrams might be able to express that clearly and keep those concerns separate, in the underlying model, the value starts looking like a concentrator, a bit of a hub. And once that kind of effect starts taking hold, the model can no longer tell whether stakeholder 1 and 2 and 3 all see the same value in A and B, or is it 1 and 2 see A and 2 and 3 see B. We're starting to sort of merge and compound our links within the value in a way that the model can no longer resolve them. So one of the sort of like the tips and guidance that I give in the paper is that when we're modeling that pattern of a stakeholder seeing value in an asset, we use it as a tertiary link, and that way it doesn't really matter how many how complex or multifaceted the relationship between stakeholders and assets become. We always know through those tertiary associations which stakeholder sees what value in which asset, right? So these are the kind of modeling tips that we come up with as we work through the practical application of things like asset modeling. Attributes. Those of you that are maybe not so familiar with the SABSA methodology, there's another sort of like a core principle in them, rather than that goes alongside identifying the sort of capabilities of an organization that have value, is that when you're trying to build maybe like a new system, and it appears to be a kind of a black box to the stakeholders, they don't see its internal composition, but they are able to articulate what properties they want this system to have, right? Even though they don't know quite how it's going to work on the inside in the internal structure, they know that this product they're envisaging, that they're about to invest in, they want to be brand enhancing, they want it to be compliant, they want it to be extensible. So business attributes in SABSA are a way of capturing those kind of adjectives, those kind of properties that the ideal system should have. And then the security architecture is all about protecting and enhancing those properties to give them the maximum business value. Okay, so you defend a property or protect a property that you think is could impact you badly in a negative sense, and you try and enhance properties that you think you can exploit for greater reward. Now, here again, we've got a concept in SABSA, the business attribute. We've got no real corollary of it in the ArchiMate model. But what we do have is this element principle. And although the title principle doesn't lend itself seemingly to being called a business attribute, when you read the definition of a principle, it represents a qualitative statement of intent that should be met by the architecture, or a general property that applies to the system in a certain context. So taking that extensibility mode of stereotyping, of extending existing elements, I've taken principle and derived from that all the business attributes from the SABSA catalog. So now we can see that in the the user quality attributes, the property of it being accessible has got its label, it's got its definition, it's got its metrics. Just as you're meant to do in the first phase of a SABSA driven architectural analysis of the system. So those are the two main value things sorted out, the values and the business attributes. We have to be a little bit careful about the placement of those attributes, because in the ArchiMate model, principles are some sort of midway in the chain between a goal and the requirements and constraints, as though by following principles you can achieve your goal. Whereas in the SABSA world, as I say, the principle of business attribute is kind of like an idealized concept that you can enhance, you can influence, but you can't actually reach it 100%. So it actually sits at the top of the abstraction chain. So in the end, what we would like to do, for example, in the confidentiality attribute, is say, well, we can maybe achieve our idealized concept of confidentiality if our goals are protection of data at rest and protection of data in transit. And for those, we need the requirements of access control and channel encryption. That's what we'd like to say in ArchiMate. But if we were bound by that native structure, putting principles in the middle, what we would end up creating is kind of a model where confidentiality becomes kind of like a node in the middle that's breaking up our path between access control and data in transit, data at rest, and channel encryption. And again, you might be able to separate those out in diagrams, but in the underlying model, the fact that we've created a hub node there means that the model, if you try and parse the model, you can't tell the difference between access control being a means of applying confidentiality to data at rest any better than data at transit. And it's wrong. I mean, obviously, channel encryption goes with data in transit, access control goes with data in rest. We can't create these kind of hubs without destroying that associativity. We could try and separate them out into two separate stacks, but that would mean creating different flavors of confidentiality, which just feels wrong. I mean, how would you describe different flavors of confidentiality? Confidentiality is a concept. It needs to be at the top of the tree. So when we're modeling these principles, as I say, we put them at the top of the abstraction hierarchy, and we limit ourselves to only trying to influence them, not trying to realize them midway between goals and requirements. So this is kind of like a self-imposed modeling discipline, that when we're dealing with SABSA attributes rather than native ArchiMate principles, we'll only ever influence them, not try and build them in, halfway up the structure. And as a result of that, we start annotating our ArchiMate model with this kind of like a hierarchy of SABSA attributes, as you can see in this example here. So at the business level, we might say that our capabilities needs to be available, which at the next level means that our business people need to be trained, that the process needs to be recoverable, which means at the logical layers we need authentication. For the access control, we need it to be supportable, we need it to be integrity assured, which maps down to the technological layer, which means the data needs to be backed up. So at each of these stages, that decomposition of business attributes at one layer that support goals at higher layers gives SABSA its traceability of knowing how our desired controls have been realized, and at the deeper levels know why a certain control is important, because you know which business level goals it's contributing to. Again, we talked a little bit about, like the principles becoming hubs, becoming attention points. So on larger models, it's best not to include the sort of like the metrics within the principle itself. You can externalize them, and you have to remember that the singletons, because they are very abstract, they're universal, and it would be very easy to say here, for example, that recoverable is influencing availability, and you draw the influence relationship between them. But you have to remember that because of these two abstract concepts, that influence is really only an echo of some relationship that exists in a real world system. It's not that recoverability and availability are associated in the abstract universally and forever. It's only a reflection of something that is happening in our underlying model. Okay, so talked a little bit there about stereotyping here. In the security overlay, we've got a number of things that have been stereotyped. We talked about the business attributes and the value and for the value chain. We can also talk about the fact that an assessment can be a vulnerability assessment, a risk assessment, an impact assessment. Our goals become our security objectives. Our requirements become our control measures. Outcomes can be the outcome of a risk treatment process, where we're going to either accept, avoid, mitigate, or transfer the risk of a certain outcome. But again, in real ArchiMate models, the stereotype is just a naming convention. The underlying tools don't take any particular attention of it. They're just names that happen to have angle brackets, and they don't do much more than that. In terms of properties, we talked a little bit about, say, like the business information will be in an existing ArchiMate model. As security people, we need to be able to add some standard properties to that, so that we've got some consistency on how we identify data that's needs confidentiality protection or integrity protection, or has a retention period, or contains personal data. So from pretty much all of the elements in ArchiMate 3, we've had a brainstorm as to what we think are appropriate properties. And again, the limitations here are that these are simple key value pairs. It's hard to model more complex records where you might need them, and the way this is supported in different tools is different. Some allow you easy to copy and paste and reuse. Some of them require you to type this thing in every element you encounter. Also marking which elements you treat as mandatory or optional, or what the default value should be. You have to make up your own notation, your own syntax for that, but there's no inbuilt support for it, as you'd expect. Overloading relationships. Well, we see here that in standard ArchiMate, it overloads the assignment, so that when you can assign an actor to a role, you can assign an application component to a piece of functionality. You can assign a device or to a piece of system software. The assignment concept is reusable, but it doesn't mean exactly the same thing in each layer. Okay. Same here with realization. We can say a requirement realizes a goal, that an application service realizes an application process, or that a piece of information, a piece of data, is realized from the information level at the business layer, to data at the logical layer, to a file on the technological layer. All reuse of the same notation in a fairly intuitive way. And we can do the same for security. So when we have a flow of like a data flow from one process to another, well, maybe you can reuse that for trust, although it's hard to explain what exactly is flowing in that trust relationship. But it's intuitive, and we can stereotype it and make sure that the model works in that way. Again, limitations. Sometimes the most intuitive relationship you like isn't legal within the current ArchiMate standard, so we have to sometimes make compromises to get to be able to express what we'd like to express. There are fewer relationship constraints in ArchiMate 3. In ArchiMate 2, basically most relationships had to flow north from the upper layers to the from the lower layers to the upper layers. ArchiMate 3 is more relaxed about that. So we can insert, elements in what we call our conceptual layer. So between a business actor and an account, we can, in the logical layer, we can think of things like principles. We can give them authorizations. We can map those onto application roles rather than business roles, and we can create models that trace how access management is being dealt with within an IT system. Again, relationships are not always legal. We have to sometimes take the second choice. But we can give some examples of how this might work. So this would be perhaps a small example of a trust model built in ArchiMate. You can see we've reused that flow relationship to say that when this customer is being served by this commercial order service, there's a trust in the customer to provider relationship that says the merchandise is going to be supplied in perfect condition. And when by that same serving relationship, the merchant trusts that the customer will pay on time. And in our model, we can use that that grouping property. We can set a property that says that's a trust boundary, so that when we're validating our model, we can say every time we have a serving relationship or a data flow or an access across a trust boundary, it'll trigger us to look at, well, have we modeled all the trusts that might be implied by that physical relationship? We can start to use this model for tracking things like compliance. We can say that in a representation of principles and control objectives like the GDPR, we can attach those principles, control objectives, and requirements to items, services, data subjects within our modeling language. And we can check that when it comes to the end of the project, if we've identified that there's a control in that GDPR that's applicable, something in that model should be realizing it. And if the realization is not there, we've missed something. We get some sort of automatic traceability and show of compliance, not in a big spreadsheet, but just by, say, querying our model. And the way that works is, what I've done in this model is trying to highlight these relationships in red. So if we know, for example, that in an access management policy, we want our credentials to be time limited, we have defined ourselves a password standard where there's this control that passwords need to be rotated at a certain period. Then we can see both that time limited principle and the control objective apply to the password. The password is using a security service, authentication. That authentication is realized by an infrastructure service for single sign-on that is realizing all the controls in that standard. So that when we look at this application here, this business process using the application or the user using that interface, we know that that interface or that service is compliant with our access management policy because there is this closed path between the principle and the goal being applied on the password and it being traceable in the structure of the IT system to something that realizes the control that's part of that standard. It's a closed loop. And when we're looking, say, to validate our models, if we find that we've got principles, control objectives, requirements that are not part of the loop, we know we've missed something. We can demonstrate compliance, but we can also check our own completeness. So, in conclusion so far, we can express a lot of what we need to do in ArchiMate, but it can be a little bit work intensive. We've got properties like stereotypes that are just decorative parts of the language that we're using as something that's more formal. And there's limited tool supported, and it's certainly not standardization. So so far we've got to a point where we can generate good, decent documentation, but we want something more than that. We want validation, completeness, consistency, right? So the tools, the modeling tools don't give us that. But remember, we've got that XML format. We can exchange or can export out of our models a semantic representation that that's machine readable. So we can take that format out of the model, transform it with some sort of like XML tool, and come up with a new model, security enhanced, that allows us to interrogate the model that we've created. Okay, and that means that by using that security overlay, we can kind of like merge the security properties that we've been talking about in that presentation as an overlay with standard ArchiMate, and have some common system that's more complete, that we as security architects can use in the same tools and processes as our colleagues in the other architecture disciplines, right? Sorry, I had to kill that. So this is the point where it doesn't know how this works well in a webinar, but we've come full circle. And at this point, I'd like to just pose a question out there as to what do we have in common now between the ArchiMate model and the original Bridges in Königsberg problem, because there's a very important step that I'm going to try and take you through in the last 10 minutes or so of this presentation. The point is that they're both graphs. They're both graph models. If you can see, both the ArchiMate and the Bridges are collections of nodes connected by links, by arcs. And so if an ArchiMate model is a graph, and we can export it in the exchange format, why don't we do that and actually liberate it out of our ArchiMate 3 constraints and load it into the graph database? And that's what I would like to show you in the next part of the presentation. If this means just ending this part of the show, hopefully you can still see my desktop here. But I've got a very simple model, you know, like a very basic ArchiMate model here, where we've got, you know, a few elements, no real properties added. Okay, a business cost. But what we can do here is take the file, export it as the exchange format, put it in, I'll put it in a simple file here and save it. Okay, so now I will go into a simple XML editor and see where we've output that. Sorry, source. There's our PCB. That's what we've just created. And maybe you can see here that we've got, you know, some very simple standard ArchiMate elements, few little properties dug in. There's a data subject here with its angle brackets. That's a stereotype of a normal actor, but this is marking this one out as a data subject. We have to make sure that all our privacy compliance rules apply to that person and any data associated with them. But now that it's in an XML form, I can use my, you know, like transform capabilities to kind of up transform it into the security overlay version of the same model. So here now in output, I've got an out. See here? So now you can see, if I look at that same, here we've got a piece of business information, but now it's been populated with a confidentiality rating, an integrity rating, the fact that it's personal data, the fact that it's got retention years. And we could have populated this from information in the CNDB or from a schema, from numerous different sources. Somewhere here we should have our data subject. As an element in a full-blown element in their own right. If I can find them. Don't see it straight away, but in here, there we are. No, data subject. Here it is. Right. So that was a stereotype of an actor before. Now it's a full-blown element in its own right, because it's been liberated from the XML ArchiMate 3 notation. Now what I can do further, from now that I've got it in the security overlay, is transform it forwards into this output here, which is the language of a graph database. So, for example, I can take that entire model to there, copy it, bring out a simple graph browser, paste that in there, run it, and if then we refresh our map, run that, we will hopefully see. Now this is, I'm going to take away that organization grouping here because it connects to everything. It kind of, I'm just going to suppress that from the view. But now I hope that you can see that just generally by the color coding schemes of ArchiMate, if I move all our business and motivational things to the top, our applications to the middle, and our technical infrastructure to the bottom, that is the same model in a graph database that we once had in ArchiMate. Okay, it's not as easy to present to your stakeholders, but the nice thing about this model is we can now say to it, you say, you know, model, all those nodes where all those that business information that I said had GDPR implications, the one that contains personal and personal sensitive data, I want you to tell me which physical nodes that data is stored on. So we can write a simple query that says, you know, match a node that's assigned to data, that's the artifact on the object, that realizes through the two logical and business layers to a piece of business information where that business information, personally identifiable information property is either personal or sensitive personal. And when we run that, it will say, yep, the client DB server, that's where your personal data is being physically persisted, right? So again, think about the possibilities that I spoke about earlier of, you know, like Facebook, looking at your friends, analyzing little fragments of node maps, looking for patterns that have been pre-analyzed for security requirements, and being able to find those patterns in a real model and suggest the security requirements that might be applicable. Right, so I'm conscious of the time now. We've only got 8 minutes left and a little bit further to go, so I will just drop out of that a little bit prematurely and go back to our presentation. It switches views. There we are. And so that was really a lightning tour of what we're working on. So I'm doing this paper in collaboration with the SABSA Institute. There's going to be at the next COSAC conference is in October, and I've got two sessions there. One is a 1-hour seminar just introducing the security overlay because it's being launched, and then there's going to be like a 3-hour workshop in actually like working with this stuff. The COSAC conference that's all in Ireland, that's in October. There's also a COSAC in Melbourne for those of you in the Asia Pacific area. My colleague is going to do a similar type of presentation there about, it's called Have You Ever Considered Modeling? So if there's any, okay, if you'd like to come along, you're very welcome. If you'd like any follow-up, well, you've got my contact details at the end of the presentation. And with that, I'd like to hand it back to Ardian for his announcement about the trainings.
Thank you, Stephen, for delivering this very practical and detailed webinar. I would like to inform you that PCB provides training and certification services for cybersecurity and IT security courses. A PCB certificate in cybersecurity courses will show your dedication in implementing and managing various processes and frameworks, and most importantly, you will have the chance to be recognized worldwide. Now, we'll go ahead and take some time to answer some of the questions from the attendees regarding today's topic. So, from what I can see, we have a very limited time, so we'll go with 1 or 2 questions. The first question is, based on your expertise and experience, what are some of the most frequent complexities deriving from the ArchiMate model?
The most frequent complexities. I don't know, but I think, I mean, ArchiMate is not a difficult language to learn. I think it consists of only something like 30, 35 different symbols. So that once you've got like a mastery of the basic notation set, again, the fact that we're adding all the security properties through transforming, through various bits of XML manipulation, we can automatically elaborate those basic ArchiMate elements with security properties, and then it's just very often a matter of choosing the right confidentiality level or the right assurance level for access to a process. And you can either prefer to do that in the modeling tool by just like selecting out the options that you want, or you can do it with an XML editor. I mean, there are many ways of doing that. But again, the whole point of modeling is to try and reduce the complexity, because even though your underlying model does get very complex fairly quickly, even on a reasonably sized system, the fact that you can create a view for a particular stakeholder that's looking at one particular aspect means that at any point you can regenerate your documentation out of that model. You can show the stakeholder the views that they're interested in, and you can review that and get feedback very quickly, because you're not asking them to read a 40, 50, 60 page document every time and try and figure it out for themselves. Ideally, the diagrams you create, your stakeholder can recognize what they know of the system in those diagrams, and they can put you straight very quickly if you've made a false assumption, if you've missed something, and say that's why modeling not only goes quickly, but it produces better architectures. So.
Yes, thank you, Stephen. Now the next questions is more technical, and I think because of the time limitation, we will conclude the presentation with this last question. So the question is, what should we use to map non-functional requirements into subsystems or system architecture, artifacts, stereotypes, etc.?
Okay, so very often security requirements are non-functional. You're talking about assurance levels. Now, one of the things we've looked at in the paper is that, particularly when we're exposing services, we say what kind of assurance do we want to give in that service. From a security perspective, that is, how well do we want to be able to be confident that the caller of that service is who they says they are. So you have maybe assurance levels that are based on the NIST digital identity standard, or you have services that are defined more in service level agreement type of properties. So you can say what the service uptime should be, or time to respond, time to recover. And then when you're looking at realizing those controls in physical elements, like in your nodes and services, you can actually give those same properties to say what the underlying system is capable of. And that way you can spot very easily whether you have got, like a very high performance top level service that is reliant or dependent on other services that can't provide that same service level. Right, and this is one of the benefits of having sort of standard notation for services at all places in the stack. You can say not only see that the top level service is meeting what the customer's been told in their SLA, but you can see that all the dependent services are in line with delivering those figures. So that's one of the kind of like traceabilities that you can do once you've got your model in a graph database. Just looking at which services are serving others and making sure that they're meeting minimum SLAs.
Thank you, Stephen, again for this very informative session, and thank you everyone for attending today's webinar. Please be informed that this session will be recorded and posted on our website, as well as on our YouTube channel, along with the slides of the presentation. For more information about our webinars or upcoming PCB in Science conference, which I mentioned at the beginning of this session, please visit our website www.pecb.com. Thank you all and have a great day.